Radio is a wireless communication technology that transmits information, such as voice, music, or data, using radio waves, a type of electromagnetic radiation. It enables broadcasting, one way like AM/FM radio, and two-way communication like walkie-talkies or mobile radios. Radio waves have frequencies from about 3 kilohertz to 300 gigahertz and travel at the speed of light. Basic working principle radio communication involves 3 main stages: generation/modulation at the transmitter, propagation through space, and demodulation at the receiver. 1. Transmitter side. A microphone or data source converts information into an electrical audio/baseband signal. This signal modulates a high-frequency carrier wave generated by an oscillator. The modulated signal is amplified and fed to an antenna, which radiates it as electromagnetic radio waves. 2. Propagation radio waves are electromagnetic waves with oscillating electric and magnetic fields perpendicular to each other and to the direction of travel. They propagate through air, vacuum, or other media, with varying attenuation. 3. Receiver side. The receiving antenna captures the weak radio waves, inducing a small electrical signal. The receiver tunes to the desired frequency, amplifies the signal, demodulates it, extracts the original audio/data, and outputs it via a speaker or processor. Key concept: modulation. A pure carrier wave carries no information. Modulation encodes the signal onto it. Amplitude modulation, AM, varies the amplitude strength of the carrier while keeping frequency constant, simpler but more susceptible to noise/static. Frequency modulation, FM, varies the frequency of the carrier while keeping amplitude constant, better sound quality and noise rejection. Here are illustrative diagrams. Electromagnetic radio wave structure, electric and magnetic fields oscillating perpendicularly. AM versus FM modulation, how information is encoded. Basic radio transmitter and receiver block diagram. Advantages of radio communication, wireless and mobile. No cables needed. Enables communication over long distances and for moving users, vehicles, ships, etc. Broadcast capability. One transmitter can reach many receivers simultaneously, e.g. radio stations. Reliability in emergencies. Works when cellular networks fail or are overloaded. Long battery life in two-way radios. Instantaneous/group communication, push-to-talk for one-to-many. No dialing. Coverage and penetration. Different frequencies allow long range, low frequency, or high bandwidth, high frequency use. Signals can diffract around obstacles. Cost-effective, lower infrastructure costs for wide areas compared to wired systems. Good for remote or rugged environments. Noise resilience, especially FM/digital. Better in certain conditions than AM. Limitations for balance. Susceptible to interference, limited bandwidth and crowded spectrum, and range depends on power/frequency/environment. Radio remains foundational for broadcasting, aviation, maritime, emergency services, and modern wireless tech, Wi-Fi, Bluetooth, etc., are evolutions of similar principles. Modern digital radio adds encryption, clearer audio, and data features. Key differences. AM, easier to implement, longer range, but more susceptible to noise and interference. FM, better sound quality, noise rejection, but requires more bandwidth and shorter range for same power.